Welcome to the Dream Architect channel. Today we will embark on a journey into the very heart of the geological night, into a silent realm where time flows like thick resin. This is not a descent to a geographical point, but a plunge into the planet's most ancient memory, into a world that has never known the sun nor heard the sound of waves. We will descend below the mountains, below the clouds, below history itself, to hear the silent whisper of those who call this abyss their home. This is a place where science and myth merge into a single whole, where life exists in defiance of all the laws we considered immutable, in a cradle of titanic pressure and icy gloom. If you enjoy these quiet journeys, I invite you to leave a like, subscribe, or share a thought below. It helps others find their way here, one sleepy soul at a time. And now, simply breathe. Allow your eyes to grow heavy and your mind to soften. Let us begin. There exists a scar on our planet, so deep that if we were to place the world's highest peak at its bottom, its summit would still be hidden beneath kilometers of water. This is the Mariana Trench, a silent realm where pressure crushes and light dies before it is born. 11,000 meters of darkness, 11 kilometers of vertical eternity, stretching down into the very heart of Earth's geological memory. This is not just a trench in the ocean floor. It is a portal to another dimension of being, where the laws of physics are pushed to their limit. Here, in the Challenger Deep, its deepest pocket, the planet reveals its most ancient secrets. It is a place one travels to in the mind to understand what true depth and true solitude are. In this realm of solitude, water acquires weight and density, becoming an invisible press capable of bending steel. The pressure here exceeds 1,100 atmospheres, as if the weight of a heavy truck were pressing on every centimeter of your body. It is a force that compresses molecules and turns any air pocket into a deadly trap. For the human body, this is instant oblivion. But for the inhabitants of the trench, it is a cradle. Their cells, their tissues, their very biochemistry are born from this crushing embrace. They do not simply withstand the pressure. They need it as we need air. Their world is a world where the very embrace of eternity has become the condition for breathing. In this world of compressed breath, the last photon of light vanishes at a depth of just 1 kilometer, leaving below it 10 kilometers of absolute primordial darkness. This is not simply the absence of light. It is its complete and eternal exile, a gloom that has never been broken by a sunrise or a moonbeam. It is a darkness that has itself become a habitat, a canvas on which the only colors are the rare, cold flashes of bioluminescence. Eyes here are a luxury or a vestige. The inhabitants of the abyss see the world through vibrations, chemical traces, and barely perceptible changes in pressure. Their reality is woven not from images, but from sensations, from invisible currents and ghostly touches. These ghostly touches ripple through the water, the temperature of which barely exceeds the freezing point. From 1 to 4 degrees Celsius, such is the eternal cold of this abyss. This is not a biting frost, but an all-pervading, lulling coolness that slows all processes to a state of deep meditation. Metabolism here stretches unhurriedly, like resin down the trunk of an ancient tree. Life is in no rush because there is nowhere to rush to. Hearts beat to the rhythm of geological epochs, and the lifespan of some creatures can be measured in centuries. This cold is a keeper of time, a preservative that allows the abyss to remember what has long been forgotten on the surface. This guardian water is itself an ancient relic, a time traveler. The water at the bottom of the Mariana Trench is some of the oldest on the planet. It has not mixed with surface waters for hundreds, if not thousands, of years. It began its journey in the polar latitudes, where, having cooled and become saturated with oxygen, it grew dense and heavy, sinking to the very bottom. From there, driven by barely perceptible forces, it set off on a 1,000-year journey across the floor of the world's oceans. This water remembers different constellations in the sky and a different composition of the atmosphere. It is a liquid archive, a silent witness to history, flowing in eternal darkness. The memory of the abyss is recorded not only in its inhabitants, but also in its very floor, covered with a layer of viscous, finest silt. This silt, for the most part, consists of what geologists call biogenic sediment, microscopic shells of plankton that have been slowly sinking from the upper layers of the ocean for millions of years. This unending marine snow is the dust of countless generations, a chronicle of life that died above in the sunlight. Every centimeter of this silt is thousands of years of history. Plunging into it, we plunge into the past, reading a book written in calcium and silicon, a book about climate, about life, and about death. But this book also contains pages brought from beyond our world. In the deep sea silt, scientists find not only the remains of living creatures, but also microscopic particles of cosmic dust. This is the ash of burned meteors, tiny fragments of asteroids and comets that traveled through the solar system for billions of years before finding their final resting place at the bottom of the ocean. Here, protected from weathering and erosion, they are preserved in an almost pristine state. The floor of the Mariana Trench is not only a planetary archive, but also a quiet collector of stellar matter, mixing the memory of Earth with the memory of the cosmos. This mixed memory rests on a floor that is constantly moving, for the trench itself is a zone of perpetual transformation. It was born at the place where one tectonic plate, the gigantic Pacific Plate, slowly slides under another, the lighter Mariana Plate. This process, called subduction, is like a very slow, almost meditative swallowing. The ancient oceanic crust, weighed down over millions of years, bows and descends into the Earth's mantle, creating this deepest scar on the planet's face. The trench is not a static place, but a living, breathing geological process, a giant wound that never heals, because it is the very mechanism of the planet's renewal. In the depths of this ever-renewing wound, unique geological formations known as mud volcanoes are born. But instead of fiery lava, they erupt cold, mineral-rich mud and gases, such as methane and hydrogen. One of the most famous, the Champagne volcano, named for the bubbles of liquid carbon dioxide rising from its depths, is an oasis in the desert of the abyss. These volcanoes are sources of chemical energy upon which entire ecosystems, independent of sunlight, are built. These are places where life is nourished not by the heat of a star, but by the cold breath of the earth itself. The earth's breath manifests here in various forms, creating entire fields of hydrothermal activity. Besides mud volcanoes, the famous smokers also exist here. Black smokers erupt streams of water superheated to 400 degrees Celsius, saturated with metal sulfides, which, upon cooling, stain the water black. And nearby, there can be white smokers, whose vents are cooler and rich in silicon and calcium, creating whitish-colored plumes. These hot and cold towers, growing on the seafloor like the pipes of a phantom organ, play the music of life's creation, each in its own key. This music of creation sounds thanks to an amazing chemical process called serpentinization. When seawater seeps into the cracks of mantle rocks rich in the mineral olivine, it reacts with it. This reaction releases hydrogen and methane, the simplest building blocks for organic life, and also produces heat. This is a chemical soup in which, as some scientists believe, the first life on Earth could have originated. The Mariana Trench, thus, may not just be a home for strange creatures, but a living laboratory, a window into the past, showing how the first spark of consciousness could have arisen from inanimate matter. This primordial spark nourishes an invisible world of microbes, the true masters of the abyss. Here live piezophilic bacteria, which translates to pressure-loving. They do not just survive, they thrive in conditions that would tear any other cell apart. Their cell membranes have a special, fluid structure to keep from solidifying under monstrous pressure, and their enzymes are designed to function in this compressed world. These microorganisms form the base of the food chain, processing the chemicals rising from the Earth's interior and converting them into organic matter. They are the silent alchemists, turning stone into bread for the entire abyssal community. Among these alchemists are true giants of the microbial world, xenophyophories. These creatures, externally resembling amoebas, are some of the largest single-celled organisms on Earth, reaching 10 and sometimes 20 centimeters in diameter. They build themselves little houses or tests from sediment, gluing it together with their slime. Their name translates as bearers of foreign bodies because they encrust their shells with particles of the surrounding ooze. Despite their size, each is a single cell with multiple nuclei. They slowly crawl along the bottom, absorbing nutrients like ghostly gardeners tending to the fields of underwater ooze. Other ghostly creatures also roam these same fields, resembling skeletons left behind by the sea. These are sea spiders, or pycnogonids, which are not actually true spiders. Their bodies are so small that their internal organs, including part of the digestive system and gonads, are located in their legs. They move slowly along the bottom on their long, thin limbs, which can be tens of times longer than their torsos. With their proboscis, they suck the juices from soft-bodied animals like sea anemones and sponges. They are living abstractions, drawings left by evolution on the canvas of the deep-sea ooze. Even viruses, those specters on the border of living and non-living, have found their home in this extreme environment. In water and sediment samples from the Mariana Trench, unique viruses, so-called phages, adapted to infecting local extremophilic bacteria, have been discovered. They are an important part of the ecosystem, controlling the numbers of microbial populations and participating in the nutrient cycle. These are the deepest predators, invisible and silent, waging their eternal war in complete darkness. Their existence reminds us that life, in any of its forms, penetrates everywhere, even into the most inhospitable corners of the planet. In this eternal war for energy, chemosynthesis, not photosynthesis, plays the key role. If on the surface life is nourished by light, here it is nourished by chemistry. Bacteria oxidize hydrogen sulfide, methane, and other compounds to obtain energy, just as plants use sunlight. This process is the foundation of everything. Around black smokers and methane seeps, dense communities form where tube worms, mollusks, and crustaceans live in symbiosis with chemosynthetic bacteria. These are gardens that have grown not under the sun, but on the breath of the planet's interior. The breath of the interior creates a unique acoustic landscape. Although at first glance the trench seems to be a realm of absolute silence. In fact, this is not the case. Sensitive hydrophones here pick up the rumble of earthquakes occurring thousands of kilometers away, the groans of shifting tectonic plates, and even the distant noise of ship propellers from the surface. But there are also local sounds, clicks and crackles made by crustaceans, and a mysterious, low-frequency hum whose source has not yet been identified. It is like the slow, deep breathing of a sleeping giant. The abyss is not silent. It speaks a language that we are only beginning to decipher. Deciphering this language, we find in it traces of substances that would be considered poisons on the surface. The water near hydrothermal vents is saturated with heavy metals and toxic compounds like hydrogen sulfide. However, for the local organisms, this is not poison, but part of the environment, a source of food. They have developed amazing mechanisms to neutralize or even utilize these substances. Their bodies are complex chemical laboratories that have learned to thrive in conditions lethal to us. This is a reminder that the concepts of poison and medicine are relative and depend only on one's point of view and a long history of adaptation. This adaptation has given rise to creatures resembling ghosts from another world. Among the most numerous inhabitants are amphipods. These shrimp-like crustaceans are found at all depths, from the surface to the very bottom. But the deep-sea species are special. Many of them lack pigmentation, making them translucent, ghostly. Their carapaces contain aluminum, which they extract from the bottom sediment. This aluminum armor, which forms a gel on the surface of their bodies, helps them withstand the colossal pressure and chitin-dissolving enzymes. They are ubiquitous scavengers, the little janitors of the abyss. Alongside them, the seafloor is patrolled by isopods, which are known to us on land as woodlice. But in the deep, their relatives can reach gigantic sizes, a phenomenon known as deep-sea gigantism. Some species grow up to 0.5 meter in length, resembling alien armadillos. This size helps them search for food more efficiently in conditions of scarcity and go longer without eating by storing fat. These slow-moving giants roam the bottom in a perpetual search for carrion, be it the remains of a whale or fish that have sunk from the upper layers. They are the silent witnesses to feasts that happen once in a century. Among these silent witnesses glide holothurians, or sea cucumbers, which become one of the dominant life forms at great depths. Some species, such as Enypniastes eximia, nicknamed the headless chicken monster, can even swim, slowly flapping their leathery fins. They feed by passing bottom sediment through their bodies, extracting organic particles from it. They are living filters that slowly but surely process the ocean floor, playing the same role as earthworms in soil. Their unhurried movement is meditation embodied in a living being. In this meditative environment lives the deepest known vertebrate to science, the Mariana snailfish. This small, tadpole-like fish was discovered at a depth of over 8,000 meters. Its body is almost completely devoid of scales and pigment. It is gelatinous and translucent, which allows the pressure to pass through it rather than crush it. It has no swim bladder, which would be crushed at such a depth. It is the embodiment of compliance and adaptation, a creature that does not fight the abyss, but becomes a part of it. But even compliance requires ingenious engineering solutions. At a depth of 8 kilometers, the bones of the Mariana snailfish should dissolve due to the high pressure and water chemistry. However, its skeleton is not fully ossified. It consists of flexible cartilage, which does not yield to pressure in the same way as hard bone, and its skull is not solid at all. It is composed of many small, unfused bones, which allows it to remain flexible under the monstrous weight of the water. This creature, is a living lesson that true strength lies not in rigidity, but in the ability to bend without breaking. Slightly higher in the twilight zone lives one of the most astonishing creatures of the ocean, the barrelly fish, or macropinna. Its most striking feature is a completely transparent, dome-shaped forehead through which its internal tubular eyes are visible. These eyes can rotate, looking straight up to spot the silhouettes of prey against the dim light from the surface, or turn forward when the fish attacks. It is a living observatory, a floating telescope that looks at the world through its own head, reminding us that evolution is the most inventive artist. In this theater of inventions, other hunters are also found, such as bathysaurs or deep lizards, some of the most ferocious predators of the abyss. They have a long, serpentine body and a mouth full of needle-like teeth that can fold inward so as not to interfere with swallowing large prey. Surprisingly, bathysaurs are synchronous hermaphrodites. Each individual has both male and female reproductive organs, which doubles their chances of reproduction during rare encounters with a partner in the vast darkness. They are the embodiment of the "always be prepared" principle in a world where second chances are rare. Opportunity also arises thanks to a unique sense that replaces sight for many inhabitants of the abyss: the lateral line. This is a system of canals and pores on a fish's body that detects the slightest vibrations in the water. With its help, a fish can feel the movement of prey, the approach of a predator, or obstacles in complete darkness. It's like having skin that can see. For deep-sea creatures, the world is a symphony of vibrations, a map of pressures and currents. They read the water as we read a book, finding in it stories of food, danger, and life. The stories in this book are often written with light, but not sunlight, living light. Bioluminescence is the silent language of the abyss. Many creatures, from bacteria to fish, are capable of producing their own light. They use it for various purposes: to attract prey, like the anglerfish with its glowing lure, to deter predators by releasing a cloud of luminous slime, or to communicate with their own kind by sending light signals in the absolute darkness. Every flicker of light in this abyss is a word, a phrase, a cry, or a whisper in the eternal night. This whisper can be deceptive, as with the deep-sea dragonfish of the genus Malacosteus. These predators possess the unique ability to produce not only blue-green light, like most deep-sea creatures, but also red light. Most inhabitants of the abyss cannot see red light, so the dragonfish uses it like a sniper's scope in the infrared range. It illuminates its prey with a beam that the prey cannot see, and strikes from the darkness. This is the ultimate form of camouflage and hunting, a play of light and shadow, where it would seem there is only shadow. The shadow also hides amazing survival strategies, such as that of the glass squid. To defend themselves, some deep-sea squids, such as Octopoteuthis delatron, cast off not an ink cloud, but the glowing tips of their arms. The predator is distracted by the brightly flashing, writhing lure, while the squid manages to escape into the darkness. The arms grow back over time. This is an act of self-sacrifice, where a part of the body is given up to save the whole. Life in the abyss requires not only strength, but also wisdom, and a readiness to sacrifice something. By sacrificing the old, the abyss constantly creates the new, and the speed of evolution here can be paradoxically high. Isolated populations, separated by underwater ridges or vast distances, rapidly accumulate genetic differences. Each trench, each underwater canyon can be home to endemic species found nowhere else on the planet. The Mariana Trench is not just one place, but an archipelago of invisible islands, on each of which its own quiet evolutionary experiment is underway. One of these experiments led to the emergence of creatures whose metabolism has almost stopped. At great depths, there is very little food, so many organisms have adapted to extreme energy conservation. They move very slowly, or not at all, waiting for hours or days for food to fall to them. Their life cycle is stretched over decades and even centuries. The Greenland shark, which can live up to 500 years, sometimes wanders into great depths. These creatures are living clocks, measuring time at a rhythm incomprehensible to us. Time here leaves its mark even on the stones. On the slopes of the Mariana Trench, rocks up to 180 million years old have been found. These are some of the oldest sections of oceanic crust on the planet, as most of it is constantly recycled in subduction zones. These stones have witnessed the rise and fall of dinosaurs, the shifting of continents, and ice ages. Each of them is an archive, preserving the memory of a world that no longer exists. By studying them, geologists can look into Earth's deep past. Looking into the past, we see that not only animal remains, but also trees sank to the bottom. Sunken tree trunks and large fragments of wood, washed into the ocean by rivers, create unique ecosystems on the seabed known as woodfalls. The wood, rich in cellulose, becomes food for specific bacteria and fungi, as well as for unique wood-boring mollusks. These oases can exist for decades, serving as a refuge for numerous species in the desert of the abyssal plains, proving that even the death of a forest on land can give new life in the ocean's depths. These changes bring strange guests to the abyss, creating temporary oases. Sometimes the remains of large animals, such as whales, sink to the bottom. Such an event, called a whale fall, becomes a true feast for the deep sea community, one that can last for decades. First, scavengers consume the soft tissues. Then come organisms that feed on the bones, and finally, bacteria that break down the fats left in the skeleton create an oasis of chemosynthetic life. A single dead whale can give rise to an entire ecosystem that will exist for half a century. This ecosystem exists in a world where there are no seasons. On the surface, life is subject to the cycles of the sun: spring, summer, autumn, winter. In the abyss, however, eternal stability reigns. Temperature, pressure, and light levels do not change for millennia. The only seasons here are the irregular arrivals of food from above, like a whale fall, or large accumulations of marine snow. Life here does not follow a calendar, it follows chance. This forces organisms to always be ready, always in a state of waiting for a miracle or a gift from above. Sometimes, a gift from above turns out to be a curse. Unfortunately, even the deepest and most remote place on the planet has not escaped human influence. At the bottom of the Mariana Trench, at a depth of almost 11 kilometers, a plastic bag was discovered. It is a sad reminder that our world is connected by invisible threads, and the imprint of our activities reaches even those places where no human has ever been. The abyss, the keeper of ancient memory, is now forced to also keep the memory of our carelessness. But even in this carelessness, life finds a way to assert itself. On the microplastic particles sinking to the bottom, entire microbial communities form. Bacteria colonize these artificial reefs, using them as a substrate. This phenomenon has been named the plastosphere. Thus, our trash becomes a new type of habitat, floating islands for microscopic life. This is further evidence of life's incredible adaptability, its ability to turn even what we consider waste into a home. One's waste becomes another's food. This is the fundamental law of the abyss. The main food source here is marine snow, a continuous rain of organic particles, dead plankton, feces, the remains of small animals. This flow is very scarce. Only about 1% of the organic matter produced in the upper layers of the ocean reaches the bottom of the trench. Therefore, life here is the art of surviving on meager rations, the ability to appreciate every crumb that falls from the table of the life-rich upper world. To catch these crumbs, some creatures have turned into living nets. For example, the Vampiroteuthis, or vampire squid from hell, does not hunt actively. It spreads out its long, sticky filaments and simply drifts in the water column, waiting for particles of marine snow to stick to them. Then it slowly retracts the filaments and scrapes the food off them. This is a strategy of passive gathering, brought to perfection. It is a meditation of waiting, embodied in a feeding strategy. Here, feeding defines body shape, often taking it to extremes. Many deep-sea predators have huge mouths and distensible stomachs. For example, the black swallower from the genus Chiasmodon is capable of swallowing prey several times larger and heavier than itself. This is an adaptation to infrequent encounters with food. If one is lucky enough to catch something, it must be eaten whole, because the next opportunity may not come for a long time. In a world of scarcity, wastefulness is a mortal sin.
From the harsh world in the silence and warmth of one's own body, and to await the return of the sun and food. It is a temporary but strategic retreat in order to return later with renewed strength. Other creatures, however, choose not to hide and wait, but to leave, embarking on great, breathtaking migrations. Every year, millions of wildebeest and zebras cross the African savanna, following the rains and fresh pastures. Arctic terns make the longest migration in the world, from pole to pole and back, in order to always live under the summer sun. And fragile monarch butterflies fly thousands of kilometers from Canada to Mexico to overwinter, with the journey being completed by several generations. These journeys are not just movements, but deeply instinctive rituals, written into their genes, attuned to the rhythm of the planet. Migration is a strategy of life that does not wait for the world to change for it, but follows the changes, turning the entire globe into its vast but cozy home. For millions of years, the ocean was the sole cradle of life, but then the bravest and most desperate decided to venture onto land, into a completely alien and hostile world. This was one of the greatest and most difficult steps in the history of evolution, fraught with immense challenges. It was necessary to learn to breathe with lungs instead of gills, to move by overcoming the full force of gravity without the support of water, and to protect their skin and eggs from drying out under the scorching sun. The first were plants, mosses, club mosses, and lichens, which created the first soil and prepared a foothold for animals. They were the silent, green pioneers who, over millions of years of patient labor, transformed bare, lifeless rocks into a soft, breathing carpet, ready to welcome new inhabitants. To establish themselves on land and strive upward toward the sunlight, plants had to solve two fundamental problems: the problem of gravity and the problem of delivering water to the upper tiers. The answer was the ingenious invention of wood, linen, an incredibly strong and rigid polymer that permeated cell walls and allowed stems to grow upward, toward the light, without breaking under their own weight. Thus appeared the first trees, which soon formed the first forests in the planet's history. A forest is not just a collection of plants. It is a new, three-dimensional architecture of life, with its own floors, light, and shadow, giving rise to countless new ecological niches for other organisms. The evolution of trees forever changed the face and climate of the planet, making it green. The first animals to dare to come ashore were likely arthropods, the ancestors of modern insects, spiders, scorpions, and millipedes. Their durable chitinous exoskeleton, which originally served as protection in the water, proved to be ideal armor, protecting against desiccation and excellent support for the body in the air. Then millions of years later, vertebrates followed them. Ancient lobe-finned fish, such as the famous Tiktaalik, developed powerful, fleshy fins that could serve as support in shallow water and primitive lungs for breathing air. These amazing creatures were borderlanders, living on the very edge of two worlds, the aquatic and the terrestrial. Their fossils are the moment of the great transition frozen in stone, caught in a time trap. The move to land required not only a new way of breathing and locomotion, but also a new revolutionary method of reproduction. Amphibians, the first terrestrial vertebrates, still remain tied to water. Their soft eggs are defenseless against drying out and must develop in a moist environment. The real revolution was the appearance of the amniotic egg in reptiles. Its strong yet porous shell protected the embryo from desiccation and mechanical damage, while the inner membranes created its own little pond with a supply of water and nutrients. This ingenious invention allowed vertebrates to finally break away from the aquatic element and colonize the most arid and remote corners of the land. The egg became a portable cradle that could be taken anywhere. With the conquest of land and the appearance of the amniotic egg, giants reigned on the planet for long epochs. The age of dinosaurs lasted for more than 150 million years, an incredibly long time compared to the few thousand years of our civilization. They were not just ferocious monsters from movies, but an incredibly diverse and successful group of animals that occupied every conceivable ecological niche. There were giant sauropods with necks the length of a bus, peacefully munching on the tops of trees. There were armored ankylosaurs, resembling living tanks with a bony club on their tail. There were fast and likely very intelligent predators. Their world was full of sounds, smells, and colors that we can only vaguely imagine, listening to the silence of the stones. The sky of that distant era belonged not to birds but to pterosaurs, amazing flying reptiles, the first vertebrates to conquer the air. They were not dinosaurs but a separate parallel branch of evolution. Their wings were formed not by feathers but by a huge leathery membrane stretched between the body and a single incredibly elongated fourth finger of the hand. The sizes of pterosaurs range from tiny sparrow-sized creatures to Quetzalcoatlus, a true giant with a wingspan like that of a small Cessna airplane. Their silent, sharp-pointed shadows glided over the fern-covered ground long before the first true birds began to sing in the sky. The fossilized bones of dinosaurs are not just ancient remains. They are architectural blueprints of a long-gone world that we are learning to read. From them, paleontologists can reconstruct not only the appearance, but also the lifestyle of these incredible creatures. The structure and strength of the bones tell us how they moved and what weight they could bear. Cavities in the skull, where the brain was located, can tell us about their sense of smell, sight, and hearing. Even microscopic scratches on tooth enamel can reveal their diet with astonishing accuracy. Every bone found is a precious fragment of a huge mosaic that helps us piece together the picture of a long-gone, but not forgotten world. This is our quiet conversation with eternity in the language of stone. But even the kingdom of giants, which seemed eternal, was not so. About 66 million years ago, a mass extinction, caused by the impact of a giant asteroid in the area of the modern Gulf of Mexico, put an end to the age of dinosaurs. But this was not the end of life itself. It was more of a sharp and dramatic change of scenery in the great theater of evolution. While the giants ruled the world in their shadow, in burrows and undergrowth, lived small, inconspicuous, mouse-like mammals. After the catastrophe, when vast ecological niches suddenly became vacant, it was these small, warm-blooded, and survival-adapted creatures that got their chance. The Great Extinction is not only a tragedy, but also a creative force, an opportunity for a new, unexpected beginning. This was far from the first or the last great extinction in Earth's history. The most terrible and destructive was the Permian extinction, which occurred long before the dinosaurs, about 252 million years ago. It wiped out up to 96% of all marine species and 70% of terrestrial vertebrates. The cause, scientists believe, was gigantic, continuous volcanic eruptions in Siberia that released enormous amounts of greenhouse gases and ash into the atmosphere. The planet was literally suffocating in an overheated, toxic atmosphere. Life was hanging by a thread from complete and irreversible disappearance. But even from these ashes, after millions of years of silence and desolation, it was reborn, giving rise to new, amazing forms, including the first ancestors of the dinosaurs. From the ashes of the old world left by the dinosaurs, mammals arose to take the vacated stage. One of their key adaptations was warm-bloodedness, the ability to maintain a constant, high body temperature regardless of the whims of the environment. This allowed them to be active both day and night, in heat and in cold, colonizing the most diverse climatic zones. Another crucial advantage was advanced parental care. Live birth, nursing with nutritious milk, and long-term teaching of survival skills to their young. These two qualities, internal warmth and external care, became the key to their evolutionary success. Mammals brought to the world not only a new physiology, but also a new model of behavior based on family, attachment, and the transmission of knowledge. Along with warm-bloodedness and an active lifestyle, came the need for constant, high-calorie food, and with it, the complex evolution of teeth. Unlike reptiles, whose teeth are usually simple, conical, and constantly replaced throughout life, mammals develop different, specialized types of teeth. Sharp incisors to bite, long canines to hold and tear, and wide molars with complex surfaces to grind and crush food. This specialization allowed for much more efficient processing of a wide variety of food, from tough seeds to muscle tissue, and the adoption of diverse diets. Our own teeth are a quiet and durable story of what our distant ancestors ate, a history frozen in enamel and dentin. Along with mammals came fur, an amazing and multifunctional invention of evolution. It serves not only to conserve precious heat in cold climates, but also for camouflage, by blending in with the background, for communication, like the raised hackles of a wolf, and even as a very fine organ of touch, like the sensitive vibrissae or whiskers of cats and rodents. Each hair is a complex structure made of keratin. Fur can be incredibly thick and dense, like a sea otter's, creating a waterproof layer of air, or light and airy, like that of the desert fennec fox, protecting not from the cold, but from the scorching sun. It is living clothing, perfectly tailored by evolution for its owner in their unique way of life. Among mammals, there were those who decided to do the unthinkable, return to the ocean, the ancestral home of all living things. The distant ancestors of whales and dolphins were terrestrial, four-legged animals, similar to small wolves or deer, that lived on the shores of ancient seas. Over tens of millions of years of evolution, their bodies were transformed beyond recognition, adapting to the aquatic element. The hind legs gradually disappeared, leaving only tiny rudimentary bones inside the body. The front paws transformed into flippers, and the nostrils slowly migrated from the tip of the snout to the top of the head, becoming a convenient blowhole. Their amazing story, perfectly recorded in the fossil record, shows how evolution can reverse its course, returning terrestrial creatures to their cradle, the water. Other mammals decided to conquer the third element, the air. Bats are the only mammals capable of true active, flapping flight. Their wings are nothing other than astonishingly modified forelimbs. The bones of the fingers, with the exception of the thumb, became incredibly elongated in a thin, yet strong and elastic skin membrane. The patagium is stretched between them. Looking at the skeleton of a bat's wing, one can see with surprise the same basic five-finger structure as in a human hand. This is another vivid proof of how evolution, like a frugal sculptor, works with the same set of parts, creating from them a hand capable of holding a tool or a wing capable of catching the night wind. Flight, this great art of overcoming gravity, was invented at least 4 times in the history of life, completely independently, in insects, pterosaurs, birds, and bats. And each time it was a unique engineering and anatomical solution. Birds, the direct descendants of predatory dinosaurs, transform their forelimbs into wings covered with complex and asymmetrical feathers. The feather is a true miracle of nature, incredibly light, strong, and aerodynamic. Initially, feathers probably served for thermoregulation, like down, or for display behavior, like bright ornaments, and only later, after millions of years, were they adapted for flight. Thus, a simple ornament became a tool for conquering the sky and gaining freedom. A bird's beak is another masterpiece of evolutionary adaptation, a light and multifunctional structure that replaced the heavy, toothed jaw of its dinosaur ancestors. It can be thin and curved like a surgical needle in hummingbirds for extracting nectar from deep flowers, powerful and hooked, as in an eagle, for tearing flesh, long and flat, as in a duck, for filtering silt and water, or bizarrely cross-shaped, as in a crossbill, for masterfully extracting seeds from spruce cones. The beak is nature's Swiss Army knife, an ideal tool precisely fitted to the diet and lifestyle of its owner. It is a living sculpture, carved by millions of years of hunger and the unique opportunities provided by the environment. The singing of birds, which fills the forests and fields at dawn, is not just beautiful sounds. It is a complex, structured language that serves vital purposes. Through songs, birds mark the boundaries of their territory, scaring off competitors. Males perform complex areas to attract females, demonstrating their health and good genes. Birds use short, sharp calls to warn each other of danger. Many species have their own geographical dialects, and chicks learn to sing by listening to and copying their parents, much like human children learn to speak. Each dawn chorus is a complex social symphony performed by millions of voices, each telling its own story of love, home, and survival. Some birds have gone beyond simple singing, becoming true architects and artists of love. The male Australian bowerbird builds a complex structure of twigs on the ground, a bower or an arbor, which he then meticulously decorates with bright objects: blueberries, yellow flowers, iridescent beetle wings, and in the modern world, colored bottle caps and pieces of plastic. The female evaluates not the male's strength or aggressiveness, but his artistic taste, diligence, and ability to create a harmonious composition. This is an amazing example of sexual selection, where aesthetic sense becomes the main driving force of evolution. The beauty created by the male becomes an honest promise of good genes and reliability. Let's return to Earth and look at our own hands. The human hand, with its fully opposable thumb, is capable of both a powerful grip to hold a hammer and the finest, precise manipulations to thread a needle. It can clench a stone and can hold an artist's brush. But this unique structure did not arise from nothing. The same basic five-fingered plan underlies the wing of a bat, the flipper of a whale, the digging paw of a mole, and the running leg of a horse. This phenomenon is called homology, the presence of a common structural plan in different species, inherited from a common ancestor. Evolution is a frugal and inventive master that does not invent anew from scratch, but endlessly modifies and reinterprets the old. But in nature there is another, no less amazing phenomenon: convergence, where completely different species, not being close relatives, acquire strikingly similar traits by adapting to similar environmental conditions or ways of life. The wings of a butterfly, made of chitin, and the wings of a bird, made of bones and feathers, both serve for flight but have completely different origins. The eyes of an octopus and a human are incredibly similar in their structure, with a lens and a retina, but they evolve completely independently on different branches of the tree of life. This shows that for certain physical and ecological challenges, optimal engineering solutions exist, and evolution finds them again and again, following completely different paths. One of the most striking and textbook examples of convergence is the marsupial mammals of Australia. Isolated on their continent for tens of millions of years, they filled the same ecological niches as placental mammals on other continents, developing strikingly similar body forms in the process. There was the marsupial wolf, thylacine, the marsupial mole, marsupial mice, and marsupial flying squirrels, which were externally almost indistinguishable from their placental doubles. It is as if evolution conducted two independent, parallel experiments with identical initial conditions and obtained very similar, predictable results. Australia is a living museum demonstrating the power of convergent evolution, an alternate universe of mammals. Sometimes evolution does not follow a path of increasing complexity and adding new structures, but rather a path of radical simplification. Parasites are true masters of evolutionary minimalism. Living inside or on the body of their host, in an environment where food and protection are always available, they gradually get rid of everything superfluous. Digestive organs, sight, locomotion, a complex nervous system. Their bodies turn into highly efficient, almost abstract machines for feeding and reproduction. For example, a tapeworm living in the intestine is, in essence, just a tiny head with hooks for attachment and a long growing ribbon of segments, each packed with thousands of eggs. This is not degradation, but the highest degree of adaptation to a very specific and comfortable way of life. Some adaptations seem strange, grotesque, or even absurd to us, but behind each of them lies a long and logical history of survival. The giraffe's incredibly long neck is not only a way to reach high branches untouched by other animals, but also a powerful weapon in the ritual duels of males, who strike each other with their necks. The toucan's huge and bright beak is actually very light due to its cellular internal structure, and serves not for fighting, but for thermoregulation, shedding excess heat, and for obtaining juicy fruits from thin branches. Evolution does not strive for beauty in our human understanding. It strives for functionality and efficiency. And in this perfect functionality lies its own, harsh and mesmerizing beauty. Let's talk about speed, about its limits in the living world. The cheetah, the fastest land animal, is the very embodiment of speed, a living arrow shot from the savannah's bow. Its body is perfectly adapted for a short, explosive sprint, an incredibly flexible spine that works like a spring, long legs, a large chest cavity with huge lungs and heart, and even non-retractable claws that work like spikes on running shoes. But this incredible speed comes at a high price. The cheetah can only maintain its run for a few tens of seconds, after which its body overheats and it requires a long rest. Evolution is always the art of compromise. Improving one quality often comes at the expense of another. There are no perfect creatures, only those that are perfectly adapted to their narrow niche. At the other opposite end of the speed spectrum is the sloth, whose name has become synonymous with slowness. Its unhurried nature is not a flaw or laziness, but a deliberate and very successful survival strategy. By moving very slowly and smoothly, it conserves precious energy while feeding on low-calorie leaves and remains practically invisible to predators with keen eyesight, such as harpy eagles. Microscopic green algae even grow in its fur, serving as additional camouflage in the rainforest canopy, making it resemble a moss-covered branch. The sloth is living, peaceful proof that in the great race for survival, the fastest does not always win. Sometimes the one who knows how to hide best and conserve energy wins. Evolution occurs not only at the level of whole organisms, but also at the invisible molecular level inside each of us. Our immune system is a field of a relentless evolutionary arms race between us and pathogens. When a virus or bacterium enters the body, special cells of the immune system learn to recognize them and launch the production of billions of unique antibodies, perfectly suited to the invader. But pathogens also evolve, constantly changing the proteins on their surface to become invisible to our immunity. This endless, quiet dance of attack and defense occurring inside our bodies every second is a microcosm of evolution in action, dynamic and intense. This endless dance is perfectly described by the Red Queen hypothesis, named after a character from Lewis Carroll's Through the Looking Glass, who had to run as fast as she could just to stay in the same place. Similarly, species in an ecosystem must constantly evolve and adapt simply to maintain their position relative to predators, parasites, and competitors, who in turn are also not standing still and are constantly improving. The entire living world is in a state of a continuous, dynamic race, where rest and immutability mean falling behind and ultimately extinction. This quiet but unceasing tension is the main engine of all the amazing diversity of life on our planet. The genetic code written in DNA molecules is not a static stone tablet, but a living, constantly edited text. Mutations, random and unpredictable changes in this text, are the raw, unprocessed material for evolution. The vast majority of them are neutral or harmful, like typos that make a word meaningless. But occasionally, by pure chance, a mutation occurs that gives an organism a small but significant advantage in its environment. Over time, through generations, this beneficial trait, favored by natural selection, can spread throughout the entire population. Evolution is a blind but relentless process that sifts through billions of random typos to find and preserve the few that become meaningful sentences in the great book of life. Sometimes evolution takes unexpected leaps, using old existing genes and structures for entirely new functions. This phenomenon is called exaptation or pre-adaptation. For example, the crystalline proteins that make up the transparent lens of our eye originally performed completely different, routine metabolic functions in cells, protecting other proteins from stress. But in the course of evolution, they were called to new service, to become the building material for a lens capable of refracting light. Evolution is like a brilliant but very frugal inventor who rummages through a box of old parts and suddenly finds a completely new, unexpected, and brilliant application for some gear. Some genes, seemingly having long lost their function, still lie dormant in our DNA like ghosts of the past. These are so-called pseudogenes or genetic fossils. For instance, humans and other primates have an inactive, broken gene for synthesizing vitamin C, which is quite active in most other mammals. Our distant ancestors probably lost it without harm to themselves because their diet was rich in fruit. These genetic relics are like abandoned, overgrown stations on the map of our genome, silent signposts reminding us of the long and winding path we have traveled and the worlds we have left behind. Sometimes it's not just inactive genes that remain in our DNA, but entire traces of ancient viral infections. Millions of years ago, retroviruses similar to HIV inserted their genetic material into the DNA of our ancestors' cells. If this happened by chance in germ cells, sperm or eggs, the viral DNA began to be passed down from generation to generation. Today, scientists estimate that up to 8% of the human genome consists of such endogenous retroviruses. Most of them are inactive and harmless, but some, it turns out, play an important role, for example, in the formation of the placenta. Thus, an ancient enemy has become an integral and even useful part of ourselves, proving once again that in evolution, there is no clear line between self and other. Evolution has also shaped our behavior, our deepest instincts and emotions. Many of our automatic reactions and preferences have deep evolutionary roots, stretching back to the time of our hunter-gatherer ancestors. The instinctive fear of heights, snakes, or spiders, the love for sweet and fatty foods that were a rare and valuable source of calories, the acute need for social connections and belonging to a group. All of this once helped our ancestors survive in a harsh world. Our modern brain is not a blank slate, but a palimpsest on which a thin layer of modern culture is written over ancient texts carved by selection. We carry within us the quiet but persistent echo of the savanna, the forest, and the cave. One such ancient and beautiful manifestation is play. Young animals of many species, kittens, puppies, fox cubs, bear cubs, spend a huge amount of time and energy on seemingly pointless roughhousing, play fights, chases, and ambushes. This is not just entertainment, but a crucial and serious school of life. In the safe environment of play, they hone their hunting skills, learn social hierarchy, develop coordination, and muscle strength. Play is evolution's ingenious way of teaching the next generation the complex art of survival through joy, curiosity, and pleasure. It is a dress rehearsal for adult life, conducted to the accompaniment of carefree laughter and romping. Let's consider the sense of smell, the most ancient, most direct, and most subconscious of our senses. Unlike sight or hearing, signals from olfactory receptors go directly to the brain's limbic system, an ancient region responsible for emotions and the formation of long-term memory. This is why a specific, long-forgotten scent can instantly and with incredible force transport us to the distant past, reviving vivid memories and feelings. For our ancestors, the sense of smell was a vital tool for finding food, detecting predators, and choosing a healthy mate. Today, we live in a world where sight and hearing dominate, but this ancient, silent language of smells still secretly and powerfully governs our state and behavior. The evolution of our sense of taste also tells a fascinating story of survival. Our instinctive love for sweetness is a legacy from our primate ancestors, for whom sweet, ripe fruits were a most valuable source of quick and safe energy. Our craving for salt is linked to the fundamental need to maintain the body's water-salt balance, especially in hot climates. And we instinctively dislike and reject bitterness because many poisonous alkaloids and toxins in plants have precisely this bitter taste. Our taste receptors on the tongue are wise and ancient advisors, handed down to us from the deep past. They still whisper to us what is beneficial and what is potentially dangerous. Even yawning, this simple, everyday, and surprisingly contagious act, has its own deep evolutionary explanation. One of the leading theories states that the deep inhalation and subsequent exhalation during a yawn help to cool an overheated brain by increasing the flow of cooler, venous blood to the head. And its striking contagiousness is possibly a vestige of an ancient mechanism for empathy and synchronizing group behavior. When one member of a primitive pack yawned, preparing for sleep, or conversely, waking up, the others would unconsciously do the same to maintain the group's overall rhythm of life. So when you contagiously yawn in response to someone else's yawn, you may be participating in an ancient social ritual of unity. Evolution has also left its marks on our body in the form of vestigial structures, organs or reflexes that have lost their original function but have not yet completely disappeared. Our coccyx is all that remains of the tail that our distant primate ancestors had and used for balance. The goosebumps reflex is the reaction of tiny muscles that, in our densely furred progenitors, would raise their fur to appear larger and more intimidating, or to create an insulating layer of air for warmth. And the appendix was possibly part of the digestive system that helped to digest coarse plant matter. These small imperfections are not mistakes, but precious punctuation marks in our long and complex evolutionary history. One of the key and pivotal events in human evolution was upright walking, or bipedalism. By standing on two legs, our ancestors freed their hands to create and use tools, to carry food over long distances, and to hold helpless young. This changed everything. Our skeleton, the shape of our pelvis, the structure of our feet, our way of interacting with the world. Walking on two legs, as it turned out, is also a very energy-efficient way to travel long distances across open terrain, which was vital in the conditions of the African savanna, where resources were scattered. Every step we take today is a quiet, unconscious repetition of that very first, uncertain, but fateful step taken millions of years ago. The freed hands became a blank canvas for the further evolution of our mind. The development of fine motor skills, the ability for precise and complex finger movements, went hand in hand with the development of the corresponding areas of the brain. The creation and use of the first stone tools required not only dexterity, but also planning, imagination, foresight of the result, and the ability to learn. The hand that learned to rhythmically strike one stone against another to make a sharp blade paved a direct path to the hand that builds spaceships, writes symphonies, and gently strokes a child's head. Our hands are the physical, material embodiment of our intelligence and our ability to change the world. A key moment in this story, a true breakthrough, was the mastery of fire. Fire gave our ancestors not only warmth on cold nights and reliable protection from predators. The thermal processing of food over fire made it safer, more nutritious, and more easily digestible. This, according to one theory, removed the energy constraints on the growth of our brain, the most energy-intensive organ. But even more importantly, the campfire became the first center of social life, a place where group members gathered together, shared food, told stories, and strengthened bonds. Fire did not just warm bodies, it ignited the first spark of culture and community, turning the frightening night from a time of fear into a time for reflection and communication. The development of the human brain is another fascinating chapter in this quiet saga. Our brain is an incredibly expensive organ to maintain, consuming up to 20% of the body's total energy, although it makes up only 2% of body mass. Its explosive growth in the hominin line was likely linked to a shift to a more calorie-dense diet, including meat and, no less importantly, to the increasing complexity of social life. The need to remember who in the group was a friend and who was a foe, to predict the behavior of fellow group members, to deceive, to cooperate in hunting, all this was a powerful stimulus for the development of social intelligence. Our huge brain is, above all, a social organ, created to navigate the complex world of human relationships. Along with the brain as its logical extension, language also developed, the most complex and flexible communication system on the planet. The ability to convey abstract ideas, to speak of the past and the future, to invent and tell stories, this is what perhaps most distinguishes us from other species. Language allowed knowledge to be accumulated and transmitted not genetically, but culturally from generation to generation, creating what we call culture. Cultural evolution, based on learning, became a new, much faster and more powerful form of evolution, built on top of the slow and conservative biological one. We are unique creatures, woven in equal measure from genes and from the stories told to us. For a long time, for hundreds of thousands of years, our ancestors Homo sapiens shared the planet with other human species. Neanderthals, our closest extinct relatives, were not the primitive, half-wild savages they were long depicted as, but complex and highly adapted beings. They created sophisticated stone tools, hunted mammoths, cared for their sick and elderly, buried their dead, and possibly had their own language and symbolic thought. The genome of many modern humans outside of Africa contains a small but significant portion of Neanderthal DNA, a quiet genetic reminder that our histories once intersected. Their world vanished, but a part of them lives on in us. But we are not as alone at the top of the intellectual tree as we sometimes think. Many animals exhibit astonishing cognitive abilities that force us to reconsider the concept of intelligence. New Caledonian crows can create and use complex compound tools to obtain food. Dolphins have a complex social structure, culture, and perhaps even their own individual signature whistles. Elephants are known to mourn their dead, recognize themselves in mirrors, and possess phenomenal memories. By studying animal intelligence, we are beginning to understand that intelligence is not a human monopoly, but a broad spectrum of abilities with many forms and manifestations throughout the living world. Octopuses occupy a special, almost alien place in this pantheon of intelligence. With their 8 flexible, sucker-covered arms, each containing its own neurons and capable of acting semi-autonomously, and a large, complex brain, they are undoubtedly the most intelligent of all invertebrates. Octopuses are capable of learning by solving complex problems, remembering people, using tools like coconut shells for shelter, and even displaying clear curiosity and playful behavior. Their intelligence evolved along a completely different evolutionary path from ours, over the course of 500 million years. Encountering the mind of an octopus is like meeting an intelligent alien living in the depths of our own world. Evolution did not stop in the past. It continues today, right before our eyes, although its pace is usually too slow for us to notice in everyday life. But in the world of microorganisms, where generations change in minutes or hours, we can observe it in real time. The rapid development of antibiotic resistance in bacteria is a classic and alarming example of natural selection in action. The few bacteria in a population that happen to have a mutation protecting them from a drug survive and produce resistant offspring. Thus, in just a few years, a population can become completely immune to a drug that was once a panacea. With the advent of agriculture, man himself became a powerful force of evolution, consciously directing it at his own discretion. Artificial selection is the process by which we have bred all the unimaginable diversity of dog breeds, from the tiny Chihuahua to the giant Great Dane, from a single ancestor, the gray wolf. We took the humble wild plant, Brassica oleracea, and by selecting its different parts, created cabbage, broccoli, cauliflower, kohlrabi, and Brussels sprouts from it. All agricultural plants and domestic animals are living monuments to our ability to shape life, selecting and amplifying desired traits over generations. Our influence on the evolution of other species is not always conscious and deliberate. The construction of cities, roads, and factories creates a completely new habitat to which some species are forced to adapt or perish. Urban birds learn to build nests from cigarette butts and wire. Peppered moths in the industrial regions of England during the Industrial Revolution changed their coloration from light, which camouflaged them on birch bark, to dark, to better hide on soot-covered tree trunks. Life stubbornly and inventively sprouts through the asphalt and concrete of our civilizations, adapting and changing before our very eyes. Evolution is not a straight ladder leading from the simple to the complex, with man at the very top as the pinnacle of creation. It is more like a huge, branching, sprawling tree or bush, where each modern twig is a unique and, in its own way, perfect result of millions of years of independent development and adaptation. A bacterium living in a boiling geyser is just as well adapted to its extreme environment as we are to ours. There are no more or less evolved creatures. There is only a vast, unimaginable diversity of solutions to the same fundamental task, the task of being alive, surviving and leaving offspring in this specific place and at this specific time. Sexual reproduction, for all its inconvenience, energy cost, and risk compared to simple cloning, has become the most powerful engine of evolution and diversity. It constantly mixes the genes of two different parents, creating unique, unrepeatable combinations in each offspring. This genetic diversity within a species is its main insurance policy for the future. If environmental conditions change drastically, for example, a new disease arrives or an ice age begins, among the multitude of different individuals, there is a greater probability of finding those whose unique combination of genes will allow them to survive and adapt. Love and attraction, in their deepest biological essence, are the mechanism that gives a species plasticity and hope for the future. But not everything in this world relies on this complex mechanism. Many plants, fungi, and protists can reproduce perfectly well vegetatively or by simple division, creating their genetic clones. And some animals, for example, aphids, daphnia, or rotifers, can flexibly switch between sexual and asexual reproduction depending on the conditions. Asexual reproduction is incredibly advantageous when environmental conditions are stable and favorable. It allows for a rapid and exponential increase in population. But when hard times come, stress or a lack of resources, they switch to sexual reproduction to create genetic diversity and increase the chances of their offspring's survival in an unpredictable future. Sometimes evolution, driven by a seemingly successful strategy, reaches a dead end. The giant or Irish elk, which went extinct several thousand years ago, possessed the largest antlers of any deer in history. Their span reached almost 4 meters, and their weight 40 kilograms. These incredible antlers were the result of runaway sexual selection. Females from generation to generation preferred males with the largest and most branched antlers. But this luxurious ornament became an unbearable burden. The enormous antlers required a colossal amount of calcium and phosphorus to grow and hindered movement in dense forests. This is a classic example of how a trait that is advantageous for reproduction can become detrimental to the survival of the entire species. Let's talk about sleep, this mysterious state in which we spend a third of our lives. Sleep is a true enigma of evolution. In a state of sleep, an animal is completely vulnerable to predators. It cannot search for food, defend its territory, or find a mate. Nevertheless, absolutely all studied animals sleep, from primitive jellyfish to humans. This suggests that sleep performs some vital, indispensable function. It is likely necessary for the restoration of body tissues, for energy conservation, and most importantly, for processing information received during the day and consolidating memory. Sleep is the time when the brain, in silence, organizes its vast library, deciding what to remember forever and what to discard as unnecessary. Not all living creatures sleep in the same way. Evolution has found many amazing ways to fit this vital necessity into the most diverse lifestyles. Dolphins and whales, which need to surface constantly to breathe, practice what is known as unihemispheric sleep. One hemisphere of their brain sleeps and recovers, while the other stays awake, controlling movement and breathing. Then they switch. Migratory birds making multi-day, non-stop flights across the ocean can sleep in short bursts of a few seconds right in flight. Sleep is flexible and plastic, just like life itself. It adapts to any, even the most extreme conditions. Aging and death, which seem like a tragedy to us, are also an integral part of the evolutionary picture of the world. From the perspective of the selfish gene, an organism is merely a temporary, mortal machine for its replication and transmission to the next generation. After reproduction has occurred and offspring have been raised, from the cold viewpoint of evolution, the organism has fulfilled its main task. The mechanisms of cell repair weaken over time, and genetic errors and damage accumulate. But in this finality, there is its own deep, ruthless wisdom. The death of one generation frees up space and precious resources for another, new generation, allowing evolution to continue its endless path of trial and error. This wisdom of self-limitation is manifested even at the level of individual cells in our body. Apoptosis, or programmed cell death, is a quiet and orderly act of cellular self-sacrifice. When a cell becomes old, damaged, or potentially dangerous to the organism, like a cancer cell, it receives an internal biochemical command to self-destruct. It doesn't just burst, it neatly disassembles itself into parts, which are then absorbed by neighboring cells without causing harm or inflammation. This amazing mechanism of cellular altruism is vital for the health and proper development of a multicellular organism. Every second in our body, millions of cells quietly exit the stage so that the whole may live. Some creatures seem to have found a way to cheat aging and escape this cycle. The hydra, a tiny freshwater creature related to jellyfish, possesses an almost limitless capacity for regeneration. It is composed mainly of stem cells that constantly divide and renew its body, so it never ages in the conventional sense. Theoretically, a hydra can live forever unless it is eaten by a predator or its environmental conditions change. The naked mole rat, an unsightly subterranean rodent, lives an abnormally long time for its size, up to 30 years, and is almost immune to cancer. By studying these creatures, we touch upon the secret of biological immortality, the possibility of stopping or slowing down the clock that ticks relentlessly inside each of our cells. Another striking example is the tiny jellyfish, Turritopsis dohrnii, nicknamed the immortal jellyfish. After reaching the adult medusa stage and reproducing, it can, in case of stress, starvation, or injury, do something incredible. It settles on the seabed and reverts back to its juvenile polyp stage. New genetically identical medusa then bud off from this polyp. It is as if a butterfly, upon growing old, could turn back into a caterpillar and start its life cycle anew. This jellyfish does not conquer death, but it knows how to turn its biological time backward at a cellular level, possessing the potential for endless cyclical renewal. Evolution has created not only predators and prey in the living world, but also healers. Many plants, in the course of their evolutionary struggle against insects and fungi, have developed a complex arsenal of chemical substances that we humans have learned to use as medicines. Acetyl salicylic acid, the active ingredient in aspirin, was first derived from willow bark, where it serves to protect against pathogens. The powerful painkiller morphine is found in the opium poppy, deterring herbivores. These substances were not created for us. In the plant, they serve for defense and survival. But humans, thanks to their inquisitive minds and powers of observation, have learned to use this vast natural pharmacy for their own needs. This is another example of how deeply we are woven into the common fabric of life. Consider fungi, neither animals nor plants, but a vast, ancient, and mysterious kingdom of life that plays a key role in the biosphere. They are the planet's main decomposers, its silent gravediggers and custodians. Using powerful enzymes, they break down dead organic matter, fallen leaves, tree trunks, animal bodies, and return valuable nutrients back into the soil, making them available to plants. Without the invisible but titanic work of fungi, our forest would be buried under a many meters thick layer of dead, undecomposed wood. They close the great circle of life and death, turning an end into a new, fresh beginning and allowing life to continue indefinitely. Some of them, like the infamous fungi of the cordyceps genus, have chosen a gruesome, yet in its own way fascinating, path of highly specialized parasitism. Their microscopic spores infect specific insects, and the fungal network, the mycelium, begins to grow inside, slowly consuming the host from within and releasing substances that control its behavior. An infected ant, for example, leaves its colony, climbs a plant to a specific height in a death trance, and clamps its mandibles onto a leaf or stem. This is the ideal location for the fungus after the ant's death, to sprout a fruiting body from its head and disperse its spores onto the unsuspecting kin below. It is a grim but brilliant tale of how one life becomes an obedient puppet in the hands of another. The evolution of living beings has shaped not only the organisms themselves, but also the physical landscapes of our planet. The great coral reefs, the largest structures created by living organisms, visible even from space, were built by tiny polyps over millions of years of patient labor. These underwater cities are home to a quarter of all marine species. Beavers, by building their dams, block rivers, create ponds and wetlands, drastically changing the hydrology of entire regions and creating new life-rich habitats for hundreds of other species. Life does not just passively adapt to the planet, it actively shapes, rebuilds, and adorns it, becoming a geologist, chemist, and architect. Viruses, these enigmatic entities standing on the very border of living and non-living, are also a most powerful and underestimated factor in evolution. They not only cause diseases, but also serve as a kind of courier, transferring gene fragments between different, even very distant species, for example, from a bacterium to an insect. This horizontal gene transfer is a kind of global genetic internet that creates unexpected connections in the tree of life, allows for the borrowing of successful inventions, and significantly accelerates evolutionary changes. Viruses are not just destroyers. They are wandering messengers, constantly shuffling the planet's genetic deck, creating new, sometimes revolutionary combinations. Evolution does not always proceed smoothly and gradually, as Darwin supposed. Sometimes it occurs in leaps and spurts. The theory of punctuated equilibrium, proposed in the 20th century, states that species can exist in a virtually unchanged state for millions of years. This is called a period of stasis. And then, as a result of a sharp change in conditions or the appearance of a key innovation, change very quickly over a few thousand years, or give rise to a new species. The paleontological record often confirms this picture. New species appear in rock layers as if suddenly, without a long series of transitional forms. This is less like a slow climb up a slope and more like a long sit on one step followed by a quick step to the next. What is a species? At first glance, the question seems simple, but in biology, it is one of the most complex and debated problems. The classic biological definition states that a species is a group of organisms that can interbreed in nature and produce fertile offspring. But this definition is completely useless for billions of asexually reproducing organisms, for fossil species, or for hybrids. And what about so-called ring species, where adjacent populations can interbreed, but the two terminal populations in the ring cannot? The boundaries between species are often blurred, conventional, and indistinct, like the shades in a sunset sky. Life does not like strict frameworks and clear definitions. It is fluid and continuous. Epigenetics is a new, exciting field of research that shows that evolution can be more flexible and rapid than we thought. Epigenetic marks are tiny chemical switches on our DNA that can turn genes on and off without changing their actual sequence. These changes can be caused by environmental factors such as diet, stress, or exposure to toxins, and most surprisingly, can sometimes be inherited over several generations. It's as if the experiences an organism gains during its lifetime could leave a quiet but audible imprint on its genes, which its children and even grandchildren will hear. This erases the rigid boundary between the innate and the acquired. Let's look at evolution on the scale of entire continents. The slow but inexorable drift of continents has played a colossal role in the history of life on Earth. When continents joined to form supercontinents like Pangaea, species migrated, mixed, and competed. When they broke apart and drifted away, populations found themselves in complete isolation for millions of years and began to evolve in their own, completely unique ways, as happened in Australia or Madagascar. The history of life on Earth is inextricably linked, like a dance, to its geological history. It is a slow and majestic ballet of life in stone, lasting hundreds of millions of years, set to the music of mantle currents. Sometimes evolution repeats itself in an accelerated and miniature form on small islands. Island biogeography is a branch of science that shows how rapid adaptive radiation and speciation occur on isolated islands. Upon arriving on an island with no familiar predators or competitors, a small group of organisms begins to rapidly occupy,